we go. Right, so now we're returning to think about averages. Now, the key thing with averages is to concentrate on deviation from the mean. Let's have a look at what we mean. Now, looking at this practice problem first, I think rather than give it to you as a practice problem, I'm actually just going to demonstrate it. What's the average of 770, 772, 776, 778? Well, of course, if we're averaging four numbers together, then normally we would say, well, A plus B plus C plus D divided by 4 equals our average that we're looking for. But adding up 770, 772, 776, 778 is going to really be a pain. It's going to be far easier to say, well, let's concentrate on what the deviation is from 770. Well, that's 0, that's plus 2, that's plus 6, and that's plus 8. If we sum those deviations, then we get a total of 16 divided by the 4 items in the set. And so the deviation from 770 is 4. So our average is 774. It's going to be much quicker to think about some point where we look at that we choose, 770 in this case, and think about the deviation from that, rather than to add up all the numbers and then divide by 4 as the normal definition of an average. We could have picked 778 as our starting point and said, well, that's 8 away from it, that's 6 below it, that's 2 below it, and that's 0 below it, and said, well, that's a total deviation of minus 16 divided by 4 equals 4 less than 778 or 774. So it doesn't matter what point we pick to compare to, it just saves us a lot of unnecessary adding up. Okay, let's look at the second practice question. Again, I think I'll just rather than ask you to work it, I'll just demonstrate it. We've got 5 temperature readings across the 6 days, and we know that the average temperature reading is 28 degrees. So how can we find out, well, what's the 6th temperature reading? Well, one way would be to say, well, 28 times 6 equals, 168, and then subtract these numbers and say, well, whatever's left must be must be the temperature reading on the final day. But that actually is possibly a slow way to do it. A faster way to do it is to think about deviation from the mean. So we can say, well, on this day it was 8 below the average. On this day it was 2 above the average. On this day it was 4 below the average. On this day it was 1 below the average. And on this day it was 1 above the average. And we can think of an average, a mean, as a balancing figure, something that balances out the terms that are above the average. We know that we had one day where we were 1 degree above the average, another day we were 2 degrees above the average. We also had a day where we were 1 degree below the average, a day where we were 4 degrees below the average, and a day where we were 8 degrees below the average. So the total negative deviations are 13 degrees below the average. The total positive deviations are 3 degrees above the average. We know that our missing term, our 6th term, must balance these figures. It must make it so that instead of having 3 above the average and 13 below the average, that we've got an equal number above and below the average. So it must be 38, because that gives us another 10 degrees of positive deviation and balances it out. So rather than having to do any painful addition or painful calculations, we can just say, well, we know what the mean is, 28. Let's look at what the deviation from the mean